Chapter 3.2 exercises 13 through 20, and this has to do with exponential and logistic function modeling. In exercises 7 through 18, determine the exponential function satisfies the given conditions. And here we have 13, an initial height of 15 centimeters growing at a rate of 5.2% per week. So for this, we have our initial value is what we start out our equation. So the basic form is going to be the starting amount, which is a sub 0, times 1 plus the rate to the power of t, whatever that is. So in this case, our initial value is 18, so it's going to be 18, and we have 5.2% per week. So we have 1 plus r. Well, r is going to be 5.2 divided by 100, because that's percent. And if we divide that out, we get 0.052. So we put our 0.052 over here to the power of t for weeks. And just adding these together, we have 18 times 1.052 to the power of t, and t is in weeks. So that's going to be our equation right here, our exponential function. Oops, forgot one thing. What did I forget? I forgot height, right? So it's the height, initial height. So we'll say h, or height with respect to time. And that's going to be in centimeters, because we're looking at centimeters, units. And it'll be centimeters height, so versus time. And if we plug in 0 for t, at t equals 0, well, 1.052 to the power of 0 is 1. So our initial value would be 18 at t equals 0. Next on our problem, we have an initial mass of 0.6, and we have doubling every 3 days. Well, doubling is going to be, that's going to give us a base of 2. So we have initial mass, we'll say m sub t, m of t, right? And is equal to our initial mass, which is 0.6 times 2 to the power of, and if we're doubling, okay, we're doubling every day, we would just have 1 day, but we're doubling every 3 days. So we have to go and take this t for days and divide that by 3. So this will be our function representing the mass. Again, we have t as our variable. Here's an exponent, t over 3. Next on our problem, which is 17, we have the initial mass of 592 grams, 592 grams. So we're going to say mass m sub t, m of t, is equal to our initial amount, which is 592, and we're having once every 6 years. There are different ways of doing this. One way, the book, I think, had 2 to the negative power, but if you just have 1/2, right, 1/2, and we're going to have t divided by 6. So that's really going to be what it is. Now, If you could also write this, and the way the book wrote it is this: they had m sub t equals 592, and we had times 2, and we had negative t over 6. But I like to use the half-life form better. I prefer this one right here. So I'm going to stick with this. But there are different ways of writing these functions. Let's look at next on our problem, which is 19. In exercise 19 and 20, determine a formula for the exponential function whose values are given in the table below. Well, we're looking at the F column. We're looking at this bunch right here. I think G is for problem 20. And so we want a formula. That formula is going to be, we'll call it H. H of t is equal to our initial value, which we look at 0 for our initial value. We have 2.3. And our base we get by taking any output value and dividing it. So if we take 2.875 and divide that by 2.3, we should get our base as we go from 0 to 1, and it should be the same multiplier to get from 2.875 to 3.59375, etc. So we're going to take 2.875 divided by 2.3. So 2.875 divided by 2.3, we get 1.25. So go back to equation. So we get 1.25 to the power of t. And actually I put h of t. I really should put it down in the terms originally, right? I should put f of x, and this t here would become an x. And that would give us our values in the table. Take a stab at the even number problems. Good luck, and thank you for viewing.